Must be nice.
You're tall too from standing back.
Yeah, tall for gymnastics. It's the only thing I can do. Yeah, I guess that's how I can. Yeah, I'm gonna just stay for the first part of that lecture. Yeah, that's what else. That sounds. Okay, sounds good. Sounds so bad. Send me an email, I'll check it out and see if that'll work, okay? Okay, sounds good. Thanks.
Got 4 more minutes to say good morning.
Yeah, there you go, 4 more minutes, that's.
So, Councilman, I have a question.
Yes.
How many more quests are we gonna have?
We're gonna have at least 2 more, maybe 3. At least 2 more, maybe 3. Make sure I stop at 12:15, because I'm gonna get you guys started for sure by 12:20. Make sure I get you started for sure by 12:15. And what do you guys allow on the quest? What do you allow on the quest?
Our brains, our pencils.
Brains and a pencil, that's it, brains and a pencil. That's all you need. How many people study? Please, may I see everybody's hands? Okay, let's not blow up the COVID dashboard on Monday, okay? Let's be wise, let's be wise. So do you think the fraternities and sororities are doing a pretty good job of social distancing, or do you think it's a train wreck? What do you think? It's still a train wreck? That's what I thought, that's what I thought. It's just so hard, right? I mean, this is such a social time of life. When you're 18 to 22, it's just like genetically built into you to be in this social settings. You know, it just goes against everything to have social distance. And I'm just horrible at social distancing. I'm just a disaster. I mean, we had a birthday party for my grandson. I'm hugging everybody, you know? And then like, my wife's like, "Did you notice you hugged everybody?" And I'm like, "No." And she's, "Do you think that was a good idea?" And I'm like, "Well, I guess not now, the way you're saying it, probably wasn't a good idea. It felt good then, they're my family." So far, like there was probably 20 of us outside at a pumpkin patch. I just like, if we take down the entire family now with this event for my grandson, I'm gonna feel like an idiot. But so far, and we still have Thanksgiving and Christmas to survive. We still have Thanksgiving and Christmas to survive. All right, I'm hearing the bells. Let's stand up. Let's stand up. Stretch. Don't breathe, just stretch. We have what today? West, okay. We're gonna take it at 12:20. You're gonna be 12:20 to 12:50. Okay, let's sit back down. Before that, I've got to get through content. We were talking last time about what? We ended class last time talking about what? Maxes and min. Local maxes and local min. Being the best in your neighborhood, or being the worst in your neighborhood, like me, okay? Then we have the global max, which is like Usain Bolt, who's the best everywhere. Or you have somebody who's like me, who could be the global min, who could be the worst everywhere. Now, part of the problem is to identify local maxes. Again, the definition says, you're the local max on a domain if there's some neighborhood I where you're the biggest guy in that neighborhood. You take any other person in the neighborhood, you're bigger than they are. The min's just the opposite. There's some neighborhood where you're the smallest. And I want to show you graphically, it's not too hard to find these. How many people look at this first graph and notice there are in fact a local max and a local min? If you see that, you're like, the local max, now notice their range values. By definition, they're f of c values. And on which axis is f of c? The y-axis, so the range values. So if I'm looking at my local max, there's some interval here around 0. So at x equals 0, I have my local max, but it's not x0 that's the max, it's f of 0. And it so happens in this case f of 0 is also 0. So I have a local max of 0, which occurs at 0. Is there a local min? Is there somebody?
Yeah.
And you're like, okay, yeah, if I look here, my local min is occurring when x is 4, but my local min is the number negative 32. So I have a local min at x equals negative 4, but the local min is negative 32. Its local min is negative. There's some neighborhood where this guy is the worst. Does this make sense? So let's go down. And maybe look at this function right here. Is there a local max and is there a local min? Find them at your seats. Try to find the x value that they occur at, and try to find what number the local max and local min is. And hopefully you guys are pretty close to being done. What's the local maximum? What is the actual value of the local maximum? 3. At what value of x did it occur? 1. You can see, if you pick people in this interval, this guy's always going to be the biggest. Now, is he the biggest guy everywhere? Is he the biggest guy everywhere? And you can see over here we're getting some bigger values. There's just some elementary school that he's the fastest in. Is there a local min? At what x value does it occur?
2.
And what is the value of the local min?
2.
It also happens to be 2. Now, are there other values that are lower than that guy? Are there other values that are lower than that guy? And you're like, oh yeah, Dr. One, you got all these guys down here. But is there some neighborhood? Is there some elementary school around 2 that he's the worst? And this is graphic. How many people get the idea of at least local and local maxes and local mins, or relative is what the book uses. Unfortunately, how many of you love graphic? Nobody's hands in the air. Nobody's hands in the air. What happens when they give us a function and ask us to do the same thing? Well, it's not so bad. Because I noticed that the function is, for a local max, the function is increasing before 1 and decreasing after 1. And if I look at my local mins, the function is decreasing before 2 and increasing after 2. Now, will increasing and decreasing be on? Bleeding is what skateboarding is to me. Okay. Will increasing and decreasing be on this? Yeah, today. Yeah.
No.
Oh yeah. Okay. Good. You're like, no, Dr. Warren. Will increasing and decreasing, could that be on here? Yeah. Okay. How many people can find intervals of increase and decrease? How many people can find intervals of increase and decrease? Okay. If you had a sign chart, for increasing and decreasing, do you think you could pluck off local maxes and local mins? You know, like for example, suppose the sign chart looked like this for the derivative. Suppose I've got a derivative, and I'm just picking numbers out of the air. I'm making crap up. Do you guys get this?
Yeah.
There's no function, I'm just pulling numbers. 7. Shay, give me a number. 3. What's your name again right here? Zach, give me a number. -1. So imagine that I did the sign chart and all these guys were zeros. You factored and all those guys were zeros. Then you started testing and you found it was negative there, positive there, negative there, positive there. What does that mean about the function on this interval? Well, no, it's increasing and then decreasing, then increasing and then decreasing. So where would a local max occur? Where would a local max, at what value of x might a local max occur? -1 and
7.
when would a local min occur?
3.
Do you see it's not much harder. If you can find intervals of increase and decrease, can you find local maxes and local mins? Okay, so let's just take one problem. We'll do that. Let's see, what are the exercise? What does it say? Blah, 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 blah. I hate the words relatives. I said this for me, this means local max and if any, most of the time there will be for each function. Okay, so let's just grab, we'll just do this really quickly. Dr. Warnelfish. Let's look at number 60. Let's look at number 60. So what do I have in number 60? What do I have? What's the function they give me? You guys, I can't look at it and write it, so you guys tell me.
G of x
G of x equals,
x cubed minus 3x squared plus 5.
thank you, Lorelai. Thank you, Lorelai. So let's go hunting for local maxes and local mins. Let's first create a sign chart to look for increasing and decreasing. What's step 1? Take the derivative. You do that. And what do you guys get? What do you guys get?
3x squared minus 6x.
3x squared
Minus 6x.
minus 6x. How many people got there? How many people are there? Okay, is it nice to know when the derivative is 0 if you're creating a sign chart? Is it nice to know when the derivative is 0?
Yes.
So let's set our derivative equal to 0. We're hunting for zeros. What's the next move? What's the next move? What's the next move? Factor. Can you factor this? Can you factor this? What can you factor out of both of those? It doesn't, it's not even a hard factor. What can you do? 3x. When you do that, what do you have left? X minus 2. If you have monkey times, my brain, monkey times squirrel equals 0. What must be true about monkey or squirrel? They have to, one of them has to be 0 or both of them are going to be 0. So I've got monkey times squirrel is equal to 0. Then either 3x is 0 or x minus 2 is 0, which means my only possible solutions are x equals 0 or x equals 2. Those are the only places that make the derivative 0. What's the next step? What's the next step? What's the next step? Sign chart. So let's make a sign chart. Put your f prime, put your f prime, put your f prime. Put your 0, and put your 2. Then what does Dr. Warren do? What does Dr. Warren do after that? Put zeros there. Now let's test. Let's test. Give me a number bigger than 2. 3. 3 times 3, positive or negative? Positive or negative? 3 minus 2, positive or negative? Positive times a positive. So I know I'm positive there. Give me a number between 0 and 2. 3 times 1, positive or negative? 1 minus 2, positive or negative?
Negative.
Positive times a negative.
Negative.
I'm just going to put that one in there. I know it's going to happen. I'm saving us time, precious time. What does that tell me about my function? If the derivative is positive, then I know it's increasing. If the derivative is negative, I know it's decreasing. And then it increases. How many people get intervals of increase and decrease? They didn't ask that. They asked for local maxes and local mins. Is there any local maxes? Will there be a local maxes? Okay, the local max occurs at x equals 0. But the local max is not x equals 0, but it's f of 0. In this case, g of 0. So let's come up here. Plug a 0 into the function. They made this easy for us. Plug a 0 into the function. What do you get? 0, 0, 5. So there's your local max. Maybe that's $5. The local max occurs at x equals. I got to keep hitting this, or you'll start telling me the local max is 0. I'm like, no. It occurs at 0. The local max is the number. It's not 0. Are there any local mins? Are there any local mins? Are there places where I go down and then go back up? You're like, yeah, Dr. Warren, at 2. So I have a local min at 2, but the local min is g of 2. And I guess I'll do the math. 8 minus 12, negative 4, plus 5 is 1. So the local max is the number. The local max is the number. It occurs at. Well, sorry. The local max is the number. You guys were answering the question I wanted, even though I like saying the wrong thing. Only Harris is. The local max is 5. The local min is. The local min occurs at. Good. Good. Is this making sense? Is this making sense? Let's take a quest. Let's take a quest. Everything on the floor but your brain and a pencil. Okay, guys, listen up, listen up, listen up. It's one page, front only. It's a pretty heavy page. If something goes bad, there's blank on the back. Let me know that it's there. Leave the true falses for last. And you can, when you're done, you can leave. get extra copies, just float them into the back. You will.
Oh, wait, I
Hand those out.
yeah, I mean,
Keep sending around, guys. There should be more coming here. What's your name again?
Julia.
Thank you. Make sure you put your name on it, guys. Make sure you put your name on it.